We have already seen different types of operation on the signals. They can be listed as amplitude shifting, amplitude scaling, amplitude reversal, time shifting, time scaling, and time reversal. We have seen this operation in details in the previous lecture. In today's lecture, we will see every one of those operations on the signal without going into the details. In other words, we will just see how first we can perform all these operations on a signal. Let's take a signal xt. At first, you will shift and scale this signal xt in both time and amplitude axis, and finally we will reverse this signal xt in time and amplitude axis. After performing the operation, our new signal is yt. At first you will perform the amplitude shifting operation of the signal on this signal xt, and the new amplitude shifted signal or yt can be given as xt plus k1. This k1 is the value which determines how much shift in the amplitude will occur in the signal xt. If the value of k1 is positive, then the signal will move upwards, and if the value of k1 is negative, then the signal will move downwards by the value of k1. We will plot the two signals yt is equal to xt plus 2 and yt is equal to xt minus 3. First one is the case of upward shifting as the value of k1 is positive, and the second one is the case of downward shifting as the value of k1 is negative. When yt is equal to xt plus 2 or k1 is equal to 2, then the signal xt moves upwards by the value of 2. That's the upward shifting of the signal xt. And when yt is equal to xt minus 3 and k1 is equal to minus 3, then the signal xt moves downwards by the value of 3, and that's the downward shifting of the signal xt. And this is the amplitude shifting operation. Please watch the lecture on amplitude shifting operation to know this operation in details. Next, you will perform the amplitude scaling operation, and the amplitude scaled signal can be given by yt is equal to k2 into xt. This value of k2 will determine how much amplitude scaling is going to be performed on the signal xt. If k2 is greater than 1, then the signal amplitude will extend, but if the value of k2 falls between 0 and 1, then the amplitude of the signal xt will be compressed by the value of k2. For this case also, we will plot two signals yt is equal to 2 into xt and yt is equal to 0.5 into xt. First one is the case of amplitude expansion as the value of k2 is greater than 1, and the second one is the case of amplitude compression as the value of k2 falls between 0 and 1. When yt is equal to 2 into xt or k2 is equal to 2, then the signal xt is expanded by the value of 2, and that's the amplitude expansion of the signal xt. And when yt is equal to 0.5 into xt or k2 is equal to 0.5, then the signal xt is compressed by the value 0.5, and that's the amplitude compression of the signal xt. And so this is the amplitude scaling operation of the signal xt. Please watch the lecture on amplitude scaling operation from the Signals and System playlist to know this operation in details. Next, we will perform the time shifting operation on the signal xt, and the time shifted signal yt is equal to x of t plus k3. This value of k3 will determine how much shifting will occur in the time axis of the signal xt. If the value of k3 is positive, then the signal xt will move to the left, which is known as time advance operation. And if the value of k3 is negative, then the signal xt will move to the right, which is known as time delay operation. Now we will plot the two signals yt is equal to x of t plus 2 and yt is equal to x of t minus 3. First one is the time advance operation as the value of k3 is positive, and second one is the time delay operation as the value of k3 is negative. When yt is equal to x of t plus 2 or k3 is equal to 2, then the signal moves to the left by the value of 2, and that's the time advance operation of the signal xt. And when yt is equal to x of t minus 3 or k3 is equal to 3, then the signal xt moves to the right by the value of 3, and that's the time delay operation of the signal xt. So this is the time shifting operation of the signal xt as the signal moves to the left and right by the value of k3, but there is no change in the amplitude of the signal. Please watch the lecture on time shifting operation in the Signals and System playlist to know this process in details. Next, we will perform the time scaling operation of the signal xt, and for this, the time scale version of the signal xt is yt is equal to k4 into t. This k4 will determine how much time scaling is going to occur in the time axis of the signal xt. If k4 is greater than 1, then the signal duration will be compressed, but if the value of k4 falls between 0 and 1, then the signal duration will be extended. So we will plot the two signals yt is equal to x of 2 into t and yt is equal to x of 0.5 into t. First one is the case of time compression as the value of k4 is greater than 1, and the second one is the case of time expansion as the value of k4 lies between 0 and 1. when y is equal to x of 2 into t, and then k4 is equal to 2, and the duration of the signal xt will be compressed by the value of 2, and that's the time compression of the signal xt. And when y is equal to 0.5 into t, then the value of k4 is equal to 0.5. So the duration of the signal xt will be expanded by the value of 0.5, or it will become double, and that's the time expansion of the signal xt. Please note that all this operation only occurs in the time axis of the signal. No operation will take place in the amplitude axis of the signal, or amplitude axis of the signal will remain unchanged. Again, please watch the lecture on time scaling operation in the Signals and System playlist to know this process in details. Next, we will perform the amplitude reversal and time reversal operation on the signal xt. At first, we will perform the amplitude reversal of the signal xt, which is a form of amplitude scaling, or y is equal to k2 into xt, where value of k2 is equal to -1. And for the time reversal operation, which is the form of time scaling operation of the signal xt, or y is equal to x of k4 into t, where k4 is equal to -1. So basically we will have to plot the signal y is equal to minus of xt and y is equal to x of minus t. For the amplitude reversal, when we plot this signal yt, then simply the signal xt will be flipped by the y-axis. And for the time reversal, when we plot the signal xt will get flipped by the x-axis. That's all for the operation of all the operations of the signal. Please check out the lectures on Signals and System playlist to understand all of this operation in details. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.